Let's take a look at a problem. So we have this complex linkage here, and we are given the information that FAC, so the force in AC, which is this linkage right here, is going to be 750 pounds. Pin diameter A is 3/8 of an inch. Pin C is a 1/4 inch. The plate thickness is a 1/4 of an inch. And so we're going to find a couple things: the shear stress in pin A, the shear stress in pin C, and the bearing stress in BC. And so BC would be that stress that pin C is affecting on the linkage. So first of all, let's take a look at something here, and I'm going to draw a side view of our linkage. And it looks something like this. So here's pin A, then here's pin C going through these two down here. And let's just shade our pins in. So one thing to note is they already told us that the force in FAC is going to be 750 pounds. And so across this entire side, it's 750 pounds. But I have two plates that are being pulled on here with 750 pounds. So an important thing to note is I have 150 pounds through that entire linkage. If I do my free body diagram, I can't have 750 pounds on that one because that means that it's unbalanced and it would actually be spinning since they're off center. So these are each going to be half of that 750 pounds to have it all balance out correctly. And that's a key trick to the problem, is realizing that. And so you're probably looking at this and going, oh my gosh, Dr. Camp, there's so much other stuff going on. What are we doing with any of it? Well, this picture was taken from another problem. I'm just isolating out this FAC. Actually, the problem given is, when you solve it in the book, is go to find FAC. So I'm just going from there. I want to calculate all this other stuff. Okay, so now we have our force picture. We have our free body diagram of what's going on. So let's take a look at our different options. Well, the first is I want to find the shear stress in pin A. So the shear stress at A, it's a pin. How do we calculate that? Well, that's going to be the force that the pin is seeing, which is, since it's at A, it's this top part, it's going to see the full force of AC divided by the area over which the force is acting. So one thing to note, this is a pin. So if I'm looking at the top, this is what it looks like. It's a circle. If that's my force that's pushing on the pin, that's shearing the pin, the area of that pin is going to be the diameter of the circle, because that shear force is acting over that pin's area. So that's 750 pounds, and we will divide that by pi over 4 times the diameter squared. The diameter of that pin was 3/8 of an inch. So 3/8 inch squared. We have no units to convert. We have pounds per inches squared, so PSI, that's the normal unit, that's what we want. So there's nothing to muck around with there. So if I go and I plug this into my calculator, 6,790 PSI. So does that pin fail? Well, we don't know. We'd have to look at the material. More than likely, it is some kind of metal which will have a ultimate shear stress way in excess of 6,000 PSI. Even if we're doing aluminum, we're probably looking at about a 15,000 PSI stress factor. So not really worried about that pin too much. So now let's go look at the shear stress in C. So C is a larger pin. It's a smaller pin. It's a 1/4 of an inch. But fortunately for C, it's not seeing the full effect of that force. Because if we go back to this force picture that we drew, so each of these is only 375. It's going to be pushing on the pin with a little bit slighter of the force. You can also look at this. This is a double shearing application. So right there, we have shear on both sides. It's double shearing. And so given that, well, we know that it's going to be half the force is going to be seen. As we already drew our picture, our free body diagram, we knew that we were going to have that force in each plate anyway. And then we're going to divide it by the area. So in this case, we've got 375 pound divided by the area of the pin, pi over 4 times 1/2 inch squared. Once again, we look at it pounds per inch squared. We're all good. 7,640 PSI. So if you go and plug that into your calculator, that's what you should get. So once again, looking pretty good. So the last thing I want to know is what's the bearing stress in link C. And so what I want to look at is, okay, here's my pin. How much is that pin pushing into my linkage? And so this will use our bearing stress. And so what was our bearing stress? It's the load divided by TD. The load on 1/2 of that is going to be 375 pound. And then we're going to divide it by its projected area. So what is the projected area? The projected area is the diameter of the pin, which is 1/2 of an inch, times the thickness of the plate, which is 1/4 of an inch. So if I look at my units, pound, inch, inch, so pounds per inch squared, exactly what I expect. If I plug that in my calculator, I will get a bearing stress of 6,000 psi. And there we go. If you have any questions, please let me know. Otherwise, we'll see you next time.